Hello class. Today we're going to be talking about slope, and slope is the rate of change of a line on my graph. Specifically, it's how much my line goes up or down on the page, or on the graph rather. So in order to calculate my slope, I'm going to be finding how much my y is changing and writing that as a fraction over how much my x is changing. If I have a line with a positive slope, that is going to increase from left to right. And I always read from left to right, basically because that's how I would read a book. You would start on the left side of the page and move to the right side of the page. If I have a line with a negative slope, I'm going to start at the top and go down. So start at the left side and work my way down. If a line has a zero slope, that is going to be a horizontal line, and a line with an undefined slope is vertical. So here I want to complete the table of values in order to graph the line and find the slope of the line by looking at the graph. So here I have a table of values. I started with my standard -2, -1, 0, 1, and 2 for my x values. And then I can go ahead and substitute in each one of those x values to give me my corresponding y values. So if I plug in a -2, I get out a 6 for my y value. My y is equal to 6. If I plug in a -1, I get out a 4, so on and so forth. So then I can go ahead and graph each one of these points. When I graph these 5 points, this is what I get on my graph. And I can take this same pattern and go where I'm going down 2 and to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. I can go ahead and recreate or continue that pattern to create the rest of my grid paper here. Once I've finished graphing the points from top to bottom on my graph, I can go ahead and construct a straight line through those points. I make sure it goes through all of the points exactly as well as I can. And make sure when you create those lines that you have arrows on both sides of your line, so to represent that line would keep going forever up and to the left and forever down and to the right. So in order to look at what the slope is, so they said complete the table of values, graph the line, and then find the slope by looking at the graph. I am going to first look at what my y value does. So I'm going to go up. I'm going to track this up and then to the left. So I count up 2 spots, and that's up is a positive direction, so I'm going to get a +2, and then left is a negative direction, so I'm going to get a -1. Calculating this as the change in my y values, this little triangle means change, so change in my y values over change in my x values. So the change in my y values over change in my x values is going to be my slope. and that is represented by the little m, and that will be a 2 over a -1, and I can actually put the negative out front because another way that I could have done this, instead of going up and to the left, I could have also gone down and to the right, which would have given me a -2 and a +1, because down is negative and to the right is positive. So I could either have my 2 as the negative or my 1 as the negative, but I only get one negative sign either way. So I could rewrite this to say, to just put the negative out in front, saying that I only have one negative sign for this whole fraction. Of course, I will take a fraction, a slope fraction, where the negative sign is on the top. I will take it if the negative sign is on the bottom or out in front. I generally just write it out in front so that I know that that negative sign can go where I need it to. So let's go ahead and take a look at the next problem. Now you notice when I created the table of values for this next problem, I did not pick my standard -2, -1, 0, 1, and 2. And that's because I have that fraction. I wanted to pick numbers that basically, when I divide by 3, as my fraction is telling me to do, I'm going to be taking each of these x values and I'm going to be dividing it by 3. Remember that fraction bar can represent division too. I wanted to pick numbers that were going to be really nice to divide by 3 so that I don't have a bunch of decimals here. Could I have kept to my -2, -1, 0, 1, and 2? Of course I could. Just would make my calculations harder. It's not wrong, it's just harder. So let's go ahead and use these values. If I put in my -6 in for my x value, I end up getting this equation here. So basically I've just replaced my x value with a -6. And then in order to multiply these two fractions, I'm going to plop that -6 over 1. Multiply straight across. I get 1 times -6 is a -6. 3 times 1 is a 3. 6 divided by 3 is 2. And I forgot my negative sign. So let's go ahead and add that back in. So then my y value here is going to be a -2. I'm going to continue that for the rest of my x values that I've picked here. So plugging into the equation for the rest of my variables, I substituted in a -3, plop to that -3 over 1, multiplied straight across, I get -3 over 3, which is -1. Putting in the 0, anything times 0 is just 0. Putting in 3, substituting in 3, I get a +1, and substituting in a 6, I get a +2. Again, it's not necessary to change your x values. It just makes it so much nicer when you end up with whole numbers instead of fractions when you're graphing. And then I'm going to go ahead and put all of these x and y values on my graph. So then graphing these points and creating the line through them, this is what I ended up getting. And I didn't even need to extend those points any because -6 through +6 gave me my full line from one side to the other. So I'm going to go ahead and draw in my slope triangles just like I did here. In this case, I'm going to go up 1, to the right 3. So that's going to be up is positive 1, and to the right is a positive 3. So I get up 1, to the right 3. My slope is now going to be 1/3. My change in my y values over my change in my x values. So 1/3. So if you notice here, for number 1, I get a slope of -2, which is exactly what I have here at the beginning, right before my x value. And over here, the 1/3 for my slope is again the number right in front of my x value. So on 3 through 5, we're going to go ahead and create our slope triangles. They already did all of the hard work for us, graphing the lines. So I'm just going to go ahead and create my slope triangle. And I can go either above or below the line, it does not matter. Here I chose to go up and to the left. So up is going to be 2, and left is going to be -3. And I get a slope, my m value, and I'm not really sure why they chose m as the letter for slope. Mostly probably because that letter S means other things already, and it can easily be confused for a 5. So anyway, my slope is going to be 2 over a -3. Or again, I could write that negative sign out in front of my fraction, meaning that I only have one negative sign for that fraction. So then for number 4, I'm going to go up and to the right. So here I go up 5 and to the right 1. So then my slope is going to be 5/1. Now, if I had created my slope triangle on the other side, I would have been going down and to the left. So let's see what happens when I do that. So down and to the left, let me change my colors here to match what I'm doing. So this one was the blue one. So with this red one here, the red slope triangle, I'm going down 5, which is going to be my -5. And then left 1 is going to be -1. So anytime I go left or down, I have a negative number, and otherwise I have a positive number. So what does that look like for my slope? Well, I'm going to have a slope equal to a -5 over a -1, and a negative divided by a negative is going to be the same as a negative times a negative, which is just 5/1. So it doesn't matter which way you go. If you end up with 2 negatives or 2 positives, you'll get a positive slope. Otherwise, you'll have one of each, one negative and one positive, and you'll end up with a negative slope. On this next one, I can't really draw a triangle here. I can't go up any because then I won't be reaching my line. So I'm just going to go ahead and represent that with an arrow that says 0. I went up 0. And then I can go to the right as between any 2 points that I want, and I can go 1, 2, 3, 4 spots to the right. And what this is would be a slope of up, my change in my y values was 0 over 4, which 0 over 4 is just 0. I could also have remembered up here in my notes that I said a horizontal line is going to have a 0 slope. So whether or not you memorize that a horizontal line, this line going here across the horizon, the horizontal line, has a 0 slope, or you calculate it here as the rise or how much I'm going up and down is 0, and the run or how much I'm going left or right is 4, my change in y over my change in x is going to be 0 either way. So the next thing that we're going to be looking at is coplanar lines. Coplanar lines will never intersect. Parallel lines are coplanar lines that will never intersect, and perpendicular lines are going to intersect at a right angle. So looking at these, let's go ahead and take a look at the slope of these different sets of lines. So if I look at number 6, we can kind of see that this part up here is closer together than this part down here. These two lines, if I drew them out enough, will eventually intersect up here. So these are not going to be parallel lines. But let's go ahead and take a look at their slope. Okay, so creating my slope triangles, I go up 4 to the left 3, up 4 to the left 2. So up 4 to the left 3 is going to give me a negative 4 over 3, or a 4 over negative 3. And up 4 left 2 is going to give me 4 over 2, which is negative. And I can simplify that to negative 2. This is going to tell me, and we said that these were neither parallel or perpendicular. They're not going to meet at a 90-degree angle, and they are going to intersect. So let's go ahead and take a look at number 7. All right, so for question number 7, when I created my slope triangles, I saw something different happen. And I ended up getting the same numbers for the top dotted line and the bottom solid line. I just noticed that I mixed these two up. The solid line was the one that had the 4 and the 2. Okay, so over here again, for question number 7, each one of these has a slope of up 1 over 2. So up 1 to the right 2, that's going to be positive 1/2. And those are going to be parallel lines. So let's go ahead and try number 8. So when I go ahead and take a look at 8, I again start to see a pattern, except it's not quite what I saw with number 7. These two are clearly not parallel lines. But I am starting to see the same numbers, except my up value for the dotted line is going to be my 4, and my up value, my change in my y, is going to be 1 for this one. So I had 1 on top here and 4 on top here. So these are going to be reciprocals of each other, where I have 4 over 1 and 1 over 4. And then I also had switched signs as well. these two are going to be meeting at a right angle, so these are going to be my perpendicular lines. So based on our patterns here, what is true about the slope of two parallel lines? That would be that they have slope is the same. And then for perpendicular lines, the slopes will be negative, well, opposite reciprocals of each other. And opposite signs and then reciprocals means I'm going to be flipping the fractions. So opposite reciprocals, opposite signs and flipping the fraction for those perpendicular slopes. So then numbers 9 through 11, I'm going to have you guys try on your own to complete those problems, and we will go over those during our Google Meet.